liftoff of Falcon 9.
It's Thursday, February 25th, 2016 at 6:29 p.m. Eastern Standard Time, 11:29 p.m. Coordinated Universal Time. You are looking at the Falcon 9 on the SpaceX pad at Launch Complex 40 as it awaits a 6:47 p.m. local time launch. Welcome to the live webcast of the SpaceX launch of SES9. My name is Lauren Lyons. I am a Mission Integration Engineer here at SpaceX, and I'm standing here outside of Mission Control at company headquarters in Hawthorne, California, where you can see tons of us just waiting for this launch. We're super excited here. This is going to be the second launch of our upgraded Falcon 9 rocket, the Falcon 9 upgrade's first GTO mission, its first attempt to land the Falcon 9 upgrade on a drone ship, and on tonight's webcast, we'll be talking about the special challenges of that landing for this mission. We'll also be learning about the SES9 spacecraft and about the upgrades we made to the pad in order to launch this more powerful rocket. So let's get going.
On the screen next to me, you're currently watching the last few glints of daylight at Space Launch Complex 40. I'm Michael Hammersley, a Materials and Process Engineer in our Avionics department. Let's do a brief walkthrough of what you're looking at. First, the upgraded rocket itself. The first stage, which is what carries the satellite up to the edge of space at about 100 kilometers, and moving faster this time at about 2.5 kilometers per second at the time of separation. Usually we're a bit under that, up to 2 kilometers per second for some of our low Earth orbits. The second stage is what's going to carry the satellite, speed it up and carry it further towards its geostationary orbit, which is its final position that it's going to. And we have the fairing, or the nose cone, which is that carbon composite structure that actually holds the satellite inside of it. Just next to it, we have the transporter erector, or the strong back. This is what actually carries the Falcon 9 out from the hangar to the launch pad and then raises it up to its current position here. You can also see there's a liquid oxygen tank back here that's just finished loading up. We have several lightning towers surrounding it. Florida is one of the lightning capitals of the world, and these safely direct that energy to the ground instead of affecting some of the sensitive electronics that are actually on the vehicle. You can also see a little bit of smoke, totally normal. That's just condensation from the atmosphere from venting excess pressure. We also have a cool potential autonomous spaceport drone ship landing. After the first stage and the second stage separate, again at about 2.5 kilometers per second, the first stage will be continuing on a ballistic trajectory towards the ship. That just means it's a big arc or parabola, for those of you who remember your pre-calculus. You'll also notice below there's a mission progress bar that you can use to follow along where we are in our launch, and a countdown timer telling us how far away you are from time equals 0.
Hello again. I'm John Innsbrucker, the Falcon 9 Product Director. And as I have done for the last flights, I'll be bringing you status updates as we go through the webcast. Now, if you were with us on our last 2 flights, you saw SpaceX successfully deliver customer spacecraft into orbit, and on one flight, we actually succeeded in bringing the first stage to a landing at Cape Canaveral. And during that, you probably saw and heard a lot of energy and enthusiasm from the SpaceX team. But I want to remind the viewers that launch is hard. The SpaceX team has been reviewing their status. We've done our flight readiness review. We've done our launch readiness reviews. And a lot of blood, sweat, and tears has gone into getting ready for today's launch. And the payoff for that is just under 14 minutes away from now when we hit the moment of truth at liftoff. Now let's take a look at how the pieces are coming together for this evening's launch out of the Cape. On the Falcon 9, the good news is we're not working any problems at the moment. We did our launch readiness poll at T-minus 35 minutes and began loading liquid oxygen and RP-1 onto the first and second stage. That loading is continuing right now. Now, if we have to hold the countdown between now and T-minus 0, we probably won't get another chance to try to launch today. It takes us probably more than the time we have in the window to offload the cold liquid oxygen and load a new batch on board. And as a reminder, as we go forward from now, all the Falcon 9s use the densified propellant, the colder liquid oxygen. On the spacecraft side, The SES and Boeing team are transferring the spacecraft to internal power. They're working on no issues at the moment. The Air Force range is ready to support. And on the weather side, although we had a 20% probability of violation, everything's looking good, so let's not do anything about the weather. So coming up at 12.5 minutes, everything is go for launch.
The Falcon 9 is just a few minutes away from launching SES9, which is the 9th telecommunications satellite in the SES family and the second SES satellite that SpaceX has put into orbit. We'll be delivering SES9 to GTO, or geostationary transfer orbit, at about 38,000 kilometers high or even higher in altitude. After we drop off the spacecraft, it will use its own onboard thrusters to adjust its position and to transfer from GTO into its final geostationary orbit, or GEO as we'll refer to it here. Geostationary orbit is so high up that it orbits the planet at about the same speed that the Earth rotates. And this makes the satellite appear kind of like as a star in the sky, so it's going to be a fixed point in the sky whenever you look up. Now let's compare this to the International Space Station, which is in low Earth orbit at about 300 kilometers, which is much closer to the Earth, and therefore means that the station orbits much faster. This is why they have those spot the station nights, where you can step outside, look into the sky, and you can actually see the space station transiting across the sky. We'll be dropping SES9 over 100 times as high as the space station. Now, to get that high and to get the satellite into the best position we can, we're going to need a lot of propellant. That means we're not going to have a ton of it left over in the first stage when we fly it back down to the drone ship. And given the need to use every single last drop of that remaining propellant to burn the Falcon 9 engines to slow it down and to orient it onto the drone ship, this landing attempt is going to be one of the more challenging ones that we've done. Today's launch window is 96 minutes long, and the reason for that is because as the Earth rotates, the final orbit of the target that we're trying to drop the satellite off to isn't a fixed distance from the launch pad, which means there's certain windows where you can get to the same destination easier than others. If we had to try to launch outside of that 96-minute window, we would run the risk of not having enough propellant to get us to our desired orbit. Within that window, we can make as many attempts as necessary. And if we can't launch within that window, we'll scrub for the day and we'll try again on another date.
This is Tom Pradario. I'm a firmware engineer at the avionics department here in SpaceX. Now, with all the excitement on launch day, it's important to remember just how much work goes into preparing the Falcon 9 before the clock starts counting down. Building and prepping a rocket for launch is no easy task, and the SpaceX team has put an enormous amount of effort towards ensuring a smooth countdown today. So first off, the Falcon 9 rocket itself. We do all of our primary fabrication and assembly work on the Falcon 9 right here at our company headquarters in Hawthorne, California. In fact, right behind me through the developing crowd, you can see one of the final assembly areas for the first stage Octaweb, which is where the 9 Merlin engines are mounted to the bottom of the rocket. It may not be super visible right now, but it is back there. Once fully assembled and checked out, we ship the Falcon 9 stages on the highway to our test site at McGregor, Texas. This is where we perform full-scale tests of all vehicle systems, from the electronics and sensors all the way down to the engines. We even do static fires at our test stands, which involve holding the rocket down and firing all the engines, just like during a launch. This allows us to flush out any potential issues way ahead of launch day and ensure the highest degree of reliability in all of our launches. After the Falcon 9 is fully tested, it heads out on the highway again to the Cape Canaveral Air Force Base in Florida, where it meets its payload. Our Payload Processing Facility, or PPF, is a controlled facility at the Cape where we integrate our customer payloads on top of the Falcon 9 rocket and get them ready to launch. The SES satellite, which is today's payload, was mated to the Falcon 9 rocket just a few days ago, and then the combined rocket satellite stack was rolled out to the launch pad. The rocket is carried by the transporter erector, or strongback, which is that large metal structure currently standing to the side of the Falcon 9. Over the past day or so, engineers have been using the connection between the rocket and the ground, called the umbilical, to perform all the necessary pre-flight checks. Now, the SES team is also able to monitor their satellite via this umbilical connection, and their engineers are currently reporting go for flight. This satellite is actually a really cool piece of technology, so let's learn a little bit about their path to launch today.
SES is one of the world's largest satellite communication companies with over 50 satellites in orbit. They're based out of Luxembourg in Europe, and their services reach over 1 billion, with a B, people on the planet. SES9 is the latest satellite in their fleet, and they plan to launch 7 more satellites between now and 2017, some of which SpaceX is going to launch. As I mentioned previously, SES satellites offer all kinds of service: broadband internet coverage, data services for mobile phones, and even airplane Wi-Fi, so you can check the SpaceX subreddits from 35,000 feet. SES also broadcasts 7,000 television channels, more than any other media broadcasting platform in the world. Beyond those endless hours of channel surfing that SES makes possible, they also help make the world a better place. They have satellites that they can mobilize in just 24 hours to help with disaster communications, and satellites that enable internet access in rural areas around the world. Now for today's launch, Falcon 9 is going to put the SES9 satellite at the highest possible orbit it can, currently targeted for around 38,000 kilometers or even higher. Then after it's separated from Falcon 9, SES will use its onboard liquid propellant thrusters to perform any major launch maneuvers or adjustments, and then it'll use its electric propulsion system to help fine-tune its final position in geostationary orbit. Both Falcon 9 and SES9 have their work cut out for them today, so let's check in with John Innsbrucker and see how things are looking out on the launch pad at the Cape.
We're at T-minus 7 minutes and counting. We're continuing to count down for an on-time launch. The SpaceX team is continuing to monitor temperatures of liquid oxygen. It's important that we get the liquid oxygen cold enough onto the rocket, especially the second stage. Now earlier we did have the go, no go poll where we verified everybody was ready to enter the launch auto sequence and begin propellant loading. We're now in the launch auto sequence. Now this is a precision timing sequence between the ground computers and the Falcon 9 flight computers. What we want to do is try to test as much as we can, as close to launch as possible, to make sure everything's working. So to that end, we're moving the throttle valves on the engines. These set the power of the engine, so we're moving them through a range of motion to make sure they're working. We're also sitting there gimbaling the engines, making sure the actuators and the sensors are all connected and that the engines are able to steer the rocket through flight. And importantly, at T-minus 10 minutes, we opened the pre-valves and began chilling in the first stage engines, getting the Merlin 1D turbo pumps ready for the cold temperatures at ignition just a couple of seconds before T0. Now currently, we're coming up on internal battery power transfer, where the Falcon 9 goes from ground power to internal power. Following that, we should see the clamp arms open up around the second stage. The erector will then start to move away from the vehicle. That happens at T-minus 4.5 minutes, but you won't see any motion for a little while after that. It starts slowly and then picks up speed. Meanwhile, liquid oxygen loading is continuing. We're going to finish loading liquid oxygen onto the Falcon 9 between T-minus 3 and T-minus 2 minutes. On the spacecraft side, the SES spacecraft has gone on internal power. They're ready for an on-time launch. The ranges go, the upper altitude winds are go. So at T-minus 5 minutes and counting, everything looks good.
Now, we've talked a lot about the upgrades made to the Falcon 9 rocket, but just as important are the upgrades we've made to the launch pad systems at Space Launch Complex 40 in Cape Canaveral. These upgrades allow us to further improve reliability and launch with better processing time than ever before.
One of the upgrades we've made are to the hold-down system. The hold-downs are the clamps that physically hold the rocket to the ground while the engines come up to full power. You can see them there. They just released. We can abort up to 1 second after ignition because of how powerful those clamps are. Right next to those hold-downs are the quick disconnects. These hold the electrical lines and the fuel plumbing that connect to the vehicle. We've made adjustments to those quick disconnects, changing the types of springs that we're using there so that they're not susceptible to a particular failure mode that we identified.
Now, the second big upgrade we've made to the pad is there's a continual, or a much bigger increase in the storage of liquid oxygen. Now, as you know, the rocket runs on liquid oxygen and kerosene fuel, or RP1, and both of these fuels need to be as cold as possible before they're loaded into the rocket.
The whole point of adding all of this capacity is to shorten the recycle time, which is the time it takes to completely empty and to reload the rocket. Previously, we just had one sphere that held all of the liquid oxygen. That's actually from the Apollo test stage, which is a cool fact.
Well, so now we have two much longer cylinders. They're vacuum jacketed, so they keep that RP1 and LOX super, super cold. And all told, we now have the ability to fill the first stage in 30 minutes, and the first stage LOX and RP1 in just 50 minutes, which means that if we have to abort, we have a better shot at launching on the same day.
We've also made upgrades to the transporter erector. Because the Falcon 9 is longer and heavier and has a more powerful engine, we've had to add blast plates to the bottom so that the transporter erector structure doesn't melt at the base.
We've also added more counterweights and more powerful lift cylinders so we can have heavier payloads on top of the Falcon 9 and still raise them to a launch position without any problems. So. It sounds like we're actually getting pretty close to the liftoff. So let's turn it over to the voice loops on the pad and see what's going on.
Any word on the voice loops?
Oh, so we're getting, we're just waiting for the final confirmation.
On countdown 1, LC at T-minus 140 clock.
Right.
And
Hold on the countdown net.
Hold.
Proceeding to launch abort steps, section 64. DC verify the finals aborted and the flight computer is not started.
Launch is aborted. Flight computers are manual.
OSM verify rated safety FTS and report.
Rated safety FTS.
OSM set launch enabled to inhibit.
Inhibit.
GC verify stage 1 and stage 2 locks and RP film manifolds are vented.
Copy and work.
GC verify water and deluge ring press valve secured by launch abort idle sequence.
Confirmed.
Verify launch mount and hold down cooling are secured.
Confirmed.
Verify the TVC tank is vented.
Venting.
GC step 64.9 secure T-tap.
Work.
OSM verify nominal FTS state and report.
OIs are in safe state. FTS is on the external power. FTS state is safe.
And brake wires are disarmed.
No brake wires.
Copy that. Okay, standing by here until the strongback is up.
This is John Innsbrucker back at the Falcon 9 launch desk here on the webcast. As you've heard and listened to for the last minute or so, at T-minus 1 minute and 40 seconds, the SpaceX team had to call hold per the procedure. That stopped the countdown, and given where we are in propellant loading, that also is going to mean that we are going to be scrubbing the launch for this evening. Now, we were in the middle of propellant load. We were just wrapping up liquid oxygen loading on first and second stage. Right now, preliminary is that we were still evaluating the liquid oxygen propellant load, looking at how much time we had left in the count to finish loading the liquid oxygen. And at that time, the launch team decided that we would need to hold the countdown. So the Falcon 9 currently is not in any significant concerns. We typically have done wet dress rehearsals, static fires where we'll even light the engines and then intentionally shut them down and then drain propellants and come back and launch a couple of days later. So that's what the team's going through now. You heard a little bit of that on the countdown net over the webcast, where the team was going through the safing procedures, which are fairly standard, and we exercise these on every Falcon 9, both at the launch sites and even in Texas, where we test the first and second stages of the Falcon 9s with all of the flight engines, the tanks, propellants, and the electronics that go on board the rocket. Unfortunately, we've had to hold the count though, and that's going to bring an end to our webcast for the evening. We do not have, for the moment, a new launch attempt determined. This was our backup day. So I welcome you to check with us on our social media pages, SpaceX.com, Facebook, especially Twitter. Many of you follow our boss on Twitter. We'll probably have some information out shortly. But as I said, that's going to bring us to an end. We'd like to thank everybody that supported today and invite you to come back and watch us as we make another attempt to place the SES9 spacecraft into geotransfer orbit, hopefully within another couple of days or so here this week. And with that, I'm going to call it an evening. Thanks again, and good night.